Well, hey everybody, this is Mr. A again, ready to start up our next to last topic for the year over geometric transformations. And we're going to go through the notes that I sent or have available here in Canvas for this topic. It looks like it's a lot of notes. There's a lot of space to do work and those kind of things to help out with that. So don't be so overwhelmed. And we're going to break this down by item, by topic, subtopic. So it's not so overwhelming, and you can do it piece by piece and stay on top of it a lot better and those kinds of things. Okay, so we have this topic over transformations, and then we'll finish this in April, and then in May we have one more topic over probability, and when we're done with that, we are finished with Math 8, and you'll be ready to go on to Algebra 1. So let's go ahead and get started here. Okay, so transformations are actions that change geometric figures, and they can change the size or the location. We're going to talk about four different ways to transform a geometric figure. Okay, the transformation or transformations, as we're going to learn later on, are performed on a preimage. Now, the preimage is just an initial image. Okay, it's the image that we start with, or the picture that we start with, and then the end result of the transformation is called the final image. Okay, the four transformations we're going to learn about are translations, reflections, rotations, and dilations. Okay, and if we were in class, I would show you guys the applications for this are actually video game programming. I take you through some early video games like Pac-Man and maybe even Tetris, and show you how programmers code these different transformations into the games, and then actually show you on the Airzopoli app how I programmed the Miller Man as he moves around the board to turn when he changes when goes around a corner and looks back on the next row and those kinds of things. So this is all very relevant, even though it might seem a little abstract what we're going to do here, but it's all very relevant to something that most of you partake in every day, which is video gaming. So quick little application tidbit there for you. All right, well, let's start with translations. A translation is just basically a slide. We slide an image to one other location somewhere, a pre-image in that regard. So we have three different kinds of translations. Ones that move across or horizontal, and then we also have some that are vertical, and then we also have some that are a combination of both of those, which are diagonal. So translations are usually one of the easiest transformations to talk about because it's very easy to identify their movement and get an idea of where the final image is in relevance to the pre-image. Okay, so a couple of quick points about translations, and we're going to get going here in the notes here some. Translations do not change the size or shape of the figure, so that's important to know. So they do not change, okay? They also do not flip or turn, okay, a figure. Those flips and turns happen with other transformations. So the only thing that a translation does is it takes the figure in its appearance, in original appearance, its pre-image appearance, and just moves it to a different location. That's all it does, okay? So I have some examples in here on the bottom of page 1, okay, and top of page 2. And due for time, we're not gonna explain everything here. We're just going to go through these here real fast, and I'll have an answer key for the notes up on Canvas, and you can reference the answer key for more in-depth answers for some of these examples and those kinds of things. We're also going to skip a lot of the discussion questions on here. I'll talk about those in my speech, but I'm not going to spend time writing some of those things down. So when you see discussion question, we'll discuss it. Probably not write anything down with that. Okay. So, example 1, we're going to determine if figure 2 is a translation of figure 1. So figure 1 is the pre-image, and we're going to see if figure 2 is a translation of figure 1. So if you look at example A here, right here, for the first problem, you'll see that figure 2 is to the right of figure 1. Okay, they both look like they have the same size and shape, so they didn't change anything. So that meets criteria 1 up here. There's nothing flipped or turned from figure 2 to figure 1. The arrow still points in the same direction. So we would say that figure 2 is a translation of figure 1. So we would answer this one with a yes. Okay. Gonna go ahead and look at problem B now. Okay. And I'm going to do this one with you, then I'm going to save you C and D to do on your own. I'll pause for a minute, you can do those, and then I'll tell you the answers on those in just a minute. But let's start with problem B. So on problem B, is figure 2 a translation of figure 1? Again, figure 1 is the pre-image. So looking at this, the arrows are both the same size and shape. However, if you notice, the arrow on figure 2 is pointing down, where the arrow in figure 1 is pointing up. So another transformation was involved here beyond a translation. So this is not just a simple translation. So this is going to be a no. All right, now for problem C and problem D. We'll answer these together. I'm going to pause for just a second to give you a chance to hit your pause button and consider these on your own notes for a couple of minutes. And then you can unpause me and we'll go over the answers for C and D together, okay? So the question again is figure 2 a translation of figure 1? Okay, take a look at these two and hit the pause button and answer these, and then I'll be back with you. Okay, so on figure C, on problem C, I hope that you were able to answer that one no, because if you notice, the arrow on figure 2 is much smaller and is not pointing in the same direction as the arrow on figure 1. So that is definitely not a translation. In fact, multiple transformations were used on that one. But on problem D, since this is a diagonal slide, okay, going towards the upper right-hand corner of the page, and the actually, take that back, going to the lower left, because again, figure 1's the pre-image, okay? So it might be helpful to highlight the pre-image when you do these, so you know what one's the pre-image. That figure 2 is a translation of figure 1. The arrow's pointing in the same direction. Figure 2 is just slid a little down and left of figure 1. So this one is a translation. Okay? So I hope you guys are okay with what it means to be what a translation actually does to a shape. Because then we're going to start putting this on the coordinate plane a little bit. Okay? So that's what's happening here now. Before we do that, something very important here at the top of page 3 of your notes that we need to go over, and that's about congruency. Okay, so two figures are congruent if they have the same size and shape. Okay, that means that corresponding sides of shapes are the same length, corresponding angles have the same measure. Okay, and if you noticed, if we go back to problem D for a second, you'll notice that figure 1 and figure 2 have the same size and shape. So figure 1 and figure 2 are congruent. So a translation does produce a congruent final image. Okay, so you want to keep that in mind when you work through translations. The translations produce congruent images. Okay, so the size and shape of your final image should be the same size and shape of your pre-image. So if that isn't the case, then you made a mistake somewhere in your translation. All right, now we're going to start doing these on the plane. So I'm going to take you through the steps here on how to graph these translations on the plane so then you can do work on the coordinate plane. We're going to start applying the point 1, 3. This is going to be our custom point. We're going to start all these transformations when we do on the plane, which is a single point transformation, okay? And then we'll do bigger shapes and stuff like that later on. So plot the point 1, 3. There it is. Okay, so now it says to translate the point 4 units down. So we're kind of like this, so you know that that is the point 1, 3. Okay, and then we're going to change the color so we can keep track of the translations here. Okay, so we're going to do that one 4 units down. So I'm going to count down 4 levels from the point 1, 3 and add another point. So I'm going to count down 1, 2, 3, 4. Just like that. Okay? So that's a translation 4 down from the original point. Okay? What are the coordinates at that point? They are 1, -1. Remember, you reference order pairs from the origin. Okay, where the black lines, the bold black lines intersect, that's the origin here. Okay? And we just performed our first translation on the coordinate plane. Okay? Just 4 levels down from the level of the previous point. All right? Now, we're going to do another translation on the blue point. Okay? And we're going to move it 8 units to the left this time. Okay, so we're going to go back to the point 1, 3. We're going to move it 8 units to the left. We're going to make this a green point. Okay, so I'm going to count it out here. 1, 2, 3, 4, 5, 6, 7, 8. Right there. Okay. So that should be a translation 8 units to the left. And all we have to do now is fit the coordinates of that point. And remember, when you're counting, don't count what you start on. You just count all your moves. So you don't count the place you're starting on, just like when we've done this counting stuff before with slope and all those other things. So be careful with that. So if I count this across, it's 1, 2, 3, 4, 5, 6, 7 units left, 3 up. So the coordinates are going to be -7, 3. Okay, and then for the last translation, we're going to do a diagonal one. That contains 2 components. It contains a horizontal component and a vertical component. So if you notice here, we're going to translate the blue point, 2 units to the right and 3 units up. All right, so we're going to start and translate 2 to the right, I believe is what it said. Yep, 2 to the right, and then 3 units up. So 2 to the right, right there, and then 3 units up. 1, 2, 3, right there. 2 to the right, 3 up. Okay? That is a diagonal translation. Okay? So the coordinates at that point, I believe, 1, 2, 3, 1, 2, 3, 4, 5, 6. The point 3, 6. Okay? So we just did our first translation on the coordinate plane. Actually, our first 3 translations on the coordinate plane. Again, they're really simple once you get to do them and get familiar with them. It's just getting some practice done that you need to worry about right now and trying to figure these out on your own. Okay, so on the coordinate plane, sometimes we use something called prime notation. Okay, to let us know what's the pre-image and what's the final image. Okay. So sometimes we'll have shapes and we'll identify shapes by their vertices, like for example, triangle ABC, okay? Down here, the very bottom, triangle ABC, okay? The final image might be triangle A prime, B prime, C prime. Notice that the letters stay in the same order, okay? But we just say prime with the apostrophes there. So A prime, B prime, C prime. And that way we can distinguish pre-image from final image, okay? So we're going to try that on the next example here and go from there. So on the next example, we're going to try to actually translate a triangle. Okay, and we're actually going to do a diagonal translation. So in order to do that, we're going to plot these 3 vertices, and then we're going to connect them together to make a triangle. Okay, that's going to be our pre-image. So we're going to start with -1, -1 for point A, which is right here, okay? And then 0, 2 for point B, which is right here, and 3, 0 for point C, which is right here. And of course, you got to remember, okay, when you plot points, X is first, Y is second. So your horizontal distance is first, your vertical distance is second, okay? And again, it's from the origin. okay? If you get those swapped, you're not going to be able to do the transformations correctly. So make sure you get those correct, all right? So I'm going to go ahead and make this triangle. One side, two sides, three sides, just like that. Okay, I'll go ahead and mark the vertices too, A, B, and C, so we can keep those set together. So there's A, B, and C. Let me do that one more time so it's a little bit easier to see. A, B, C. There we go. Okay, and so we have triangle ABC on the plane. Now we're going to perform the translation. 2 units right and 5 units up. Okay, so I'm going to take every point and go 2 units right and 5 units up. We're going to start with A. Okay, so 2 units right. Whoops, I'm going to switch to the pen. So 2 units right, 1, 2, and then 5 up. 1, 2, 3, 4, 5. It's just right there, I believe. Okay, so we're going to call that point A prime. Okay, what are the coordinates of A prime? Well, it's 1, 4. 1 to the right and 4 up. So we have 1 point down and 2 more to go. Okay, we're going to do the same thing with B prime. Or with B, I'm sorry. 2 to the right and 5 up. 1, 2, 1, 2, 3, 4, 5. Puts it right there. So there's B prime. Okay, and so what are the coordinates of the point on B prime? It's 2 to the right from the origin and 7 up. So it's the point 2, 7. Okay, and then we have one more, C prime. So we're going to go 2 to the right and 5 up. 1, 2, 3, 4, 5. Right there it is, I believe. Okay, count it out. Coordinates 1, 2, 3, 4, 5 to the right. 1, 2, 3, 4, 5 up. So C prime is the point 5, 5. Now we have them all plotted. We can make our triangle. And we've completed the translation. Okay, so that's example 2. All right. So you have an example now of how to do a translation on a coordinate plane. All right, with a shape. Look at example 3. I'm going to do actually one of these with you, and you're going to be able to do the other one. Okay, so I'm actually going to do problem A, and you're going to try problem B. Okay. Actually, let's reverse that. I'll do the harder one. I'll do problem B, and you can do problem A. Okay, so let's look at problem B first. All right. Now, it might be a good idea to identify what the preimage is. So if you want to, I highlight the 1 here, so you know this is the preimage. That might be a good idea. Okay. So what we have to figure out here is what translation was applied to figure 1 to obtain figure 2. Okay. So let's go ahead and take a look at that real fast. I'm going to look here. It's definitely a diagonal translation. We're told the figures are congruent, so we know that it could be, it is going to be a translation. Okay, because the points are corresponding in order, so they didn't switch their order. So all we're going to do is I'm just going to count it. Okay, I'm just going to count my location from A to A prime in both directions. I know it's a diagonal translation. I'm just going to figure out what the units are in each direction. So I'm going to count it going across, and then I'm going to count it going upward. So 1, 2, 1, 2, 3, 4, 5, 6 to the left. I'm going from A to A prime. So that's a 6. Okay, and then 1, 2, 3, 4, 5, 6, 7 up to get to the next point. Okay, so one option, and there's actually an additional answer for problem B. One option is to translate 6 left and 7 up. Okay, so there's one option for that one. Okay, the other option, if you wanted to go up first, you could have absolutely done that. So you would have gone up 7 first. 1, 2, 3, 4, 5, 6, 7. Again. Sorry about that. My pen messed up on that one. Okay, and then 6 over. 1, 2, 3, 4, 5, 6. All right, and again, it's from A to A prime, so it's still 7 up and 6 left. But the order doesn't matter. You could have said up first or left first. Okay, so you could also have said translate 7 up and 6 left. All right. The order doesn't matter usually on a single translation. There are some times where order does matter and other times where order doesn't. Okay. Now I'm going to pause and let you try to do problem A on your own. Okay. Try to figure out the translation that's applied here to problem A. Okay. I'll pause for a second or two and then I'll catch up with you here in just a minute and tell you the answer. Okay, so on problem A, okay, if we're looking at the distance from A to A prime, because we know it's a translation, all the points get translated the same amount. So all I have to do is do it for one of them, figure out the translation for one of them, we got it for all 4 of them. So if I just count from A to A prime, it's definitely a translation going to the right. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's going to be a translation 10 units to the right. Okay, so that would be example 3. Example 4 we're going to skip. We're not going to do anything with example 4, okay? But I do want to talk about this whole thing about patterns here real fast. You might have noticed back here on example number 2 that all you had to do to get the translation was take the amounts of the translations and then add or subtract them accordingly, according to the direction that you needed to go to get the final image, okay, at each point. For example, if I take the point -1 and add 2 to that, I get +1. Right there. Okay? And likewise, if I do -1 for the y coordinate and add 5 to that, because I'm going up, so it's going to be in addition to 5. Up and right again, you add. Down and left, you will subtract. Okay? So you will notice that if I add 5 to this, I get +4 right there. And that will repeat for all the other points. Okay? So you can do the math first and get your order pairs and then plot them, or plot them and get the order pairs. So either way you want to go about it, you can go about it that way, okay? All right. And then the last major thing we have to talk about here in this first video is this idea of using symbolic representation. So I want to talk about it here for just a few minutes, okay? This is a way to show a translation just by an order pair without graphing them. So the values of A and the B represent translations up, down, left, and right. If A and B are positive, then if A is positive, it's a translation right. If B is positive, it's a translation up. And notice that A is going to always be with X. Y is always going to be with B. Okay? So, again, up and right are positive. So if it's X plus A, it's a shift right A units. If it's Y plus B, it's a shift up B units. Okay? And likewise, if it's X minus A, then it's a shift left A units. And if it's Y minus B, it's a shift down B units. So I have a few examples here for us to take a look at just to get this notation down here real fast. Okay? So notice on this one, only X has a +3. Y stays the same. Okay, so we're not changing the height. We're just changing the distance across, the horizontal distance. Plus 3, 3 units to the right. Okay, just like this. 3 units to the right. All right. Next, notice in the next one, it's a shift of y minus 5. So since it's on the y, it's going to be 5 units going down. Okay? And then on the last one, notice that both coordinates have a translation applied. So on this one we have minus 1, and on this one we have plus 2. So it's going to be a translation, 1 unit to the left. Oops, wrong color. Sorry about that. 1 unit to the left, and then 2 units upward. Okay? So the whole idea here is to then use the symbolic representation to figure out the correct transformations. We're going to actually apply this on the next page. Okay? So notice the top of page 6 here. It says each ordered pair in the figure would be translated according to the representation provided. Okay, and I give an example. If 3, 8 was a part of the figure, okay, and the translation was x plus 2y minus 4, okay, that would translate to the point 5, 4, because you're going to add 2 to 3 to get your 5, and you're going to subtract 4 from 8 to get your 4. Okay, so let's just do these examples here real fast. I'm going to do A and D, and you guys can do B and C. So I'm going to do A first, and we're going to just write the symbolic representation for A. Okay, so if I want to just show 4 units up, then what I would do is start out with my order pair, x, y. Okay, the arrow means it goes to. Okay, if it's 4 units up, x is going to stay the same. Up means add. Okay, so I'm going to do y plus 4. Okay, so I'm going to stop for a second, and I'm going to let you try to do problem B. So I'll pause. Okay, now that you've done problem B, okay, it's 3 units to the left, so let's get our notation here, x comma y, and it goes to 3 units to the left would be x minus 3. 1 unit down would be y minus 1. Okay? Now, reverse it. Here's the notation. You tell me the translation. Okay? I'm going to do D, and you can do problem C. Okay? So on D, it looks like it's plus 5. That's going to be going 5 to the right, and plus 4, which means it's going to be going up. So it's going to be a translation 5 right and 4 up. All right? Try C. Okay. Well, if you did it correctly, you should have said translate 6 to the left. Okay? And that's how the symbolic representation works. Now, the last example is going to apply this to the coordinate plane. Okay? So it's the same triangle as before. It's just a different transformation. So I want you to try this one on your own. And you can check your work with the answer key that I provide on Canvas for you, okay, on this last one. And now you're ready to do your first assignment over translations. And the next video won't be as in-depth because we've already gone over a lot of the preliminary stuff on transformations. So when we talk about reflections on the next one, we'll be able to get through it a little bit faster, okay? So this wraps up the first video, and